All right, so what is this source of stability? Why are benzene and other aromatic compounds so stable? And unfortunately, it's the answer is a bit complicated, and so it has to do with molecular orbital theory. We're just going to keep it simple and just point out two major things. And the most major component is that these electrons are spread over many orbitals slash atoms. Right. So the further we can spread out these electrons, the less electron repulsion we'll have, and the more stable our compounds are going to be. And so aromatic compounds have these very delocalized electrons. And then the second important thing is that these are kind of what's known as closed shell compounds. And so what this means is that all the bonding orbitals are filled, which is good, right? Because bonding orbitals are stabilizing, and then the anti-bonding orbitals are empty, which is also good because anti-bonding are destabilizing effects, right? And so here's the molecular orbital diagram for benzene. We have 6 p orbitals, and so we'll have 6 molecular orbitals as well. And so what you'll notice is that there's almost always going to be a single one down by itself on the bottom. And then after that, you're going to have sets of degenerate orbitals, right? And so these two are on the same energy level. And so that's known as degenerate. And then we start filling in the electrons, right? We have 6 atoms, so we have 6p electrons. And so what you'll notice is that 1, 2, 3, 4, 5, 6, right? All of those are filled. And then this line here represents the cross from these bonding orbitals to these anti-bonding orbitals. And so you can see all of our electrons are in these bonding orbitals. And if you take a look at a picture of these orbitals, you can see that the electrons really are spread out quite a good bit over this molecule. And so all cyclic conjugated systems will have similar looking orbitals. However, they won't all have the same amount of electrons, right? And so here we see the same benzene structure with its 6 electrons. And then we also take a look at naphthalene, right? It's got very similar thing where all the electrons are in these bonding orbitals. And so benzene and naphthalene here are aromatic. And then if you take a look at these two compounds, right, they're still cyclic, and so their orbitals look the same. However, now we have a different number of electrons, and now we're starting to fill in, these are actually non-bonding orbitals, and so these are not aromatic. You don't really have to know too much of this, but if you're interested into why these things are so stable, you can at least get an intro to this topic.